Statistics are used in psychology to organize and describe data collected in psychological research, as well as to make inferences about the data collected. Understanding the results of psychological research requires an understanding of statistics used. There are two types of statistical methods, descriptive and inferential. Descriptive statistics are used to summarize the data, the numbers collected in psychological research studies. Inferential statistics are used to help researchers interpret their data and decide how meaningful the results of a study are for other people. When we measure a number of instances of anything, we typically get a distribution that ranges from smallest to largest, such as city populations or the weights of newborns, or lowest to highest, such as average daily temperatures, annual income, or the heights of 1,000 male college students. Oftentimes we want to find the middle value of a distribution like this. This value is the central tendency, the typical score of the distribution of measurements. Suppose that you are enrolled in an introductory psychology course with 49 other students. The first quiz is worth 30 points, so 30 is the highest possible score. The distribution of scores ended up like this. Your score was 24. What can you conclude about how you scored in relation to other students in the course? This distribution is not very useful for making any conclusions. You could arrange these scores from lowest to highest in a rank distribution. In this order, the central tendency of the distribution of scores becomes clear. Many of the scores cluster around the values between 15 and 19. In statistics, there are three ways to describe the central tendency of a distribution: the mean, median, and mode. The mean is usually the preferred measure of central tendency because every single bit of data, including the extremely high and low scores, is included in the arithmetical calculation. The formula for calculating the mean is the sum of the individual scores divided by the total number of scores in a distribution. The mean score of the psychology quiz was 18.12, 18 if we round off to the nearest actual score. The mean score is commonly used to describe a set of scores. However, since the mean takes all data into account, it can be misleading when there is an extreme score, as an extremely high score can raise the mean significantly, and an extremely low score can lower it significantly. For example, if the two top-ranked students who scored a 28 and a 29 on this quiz scored a 0, the mean would drop to 16.98. The median is the midpoint of a distribution in which 50% of the scores fall above the median and 50% fall below. How you determine the median is dependent on how many items you have. If you have an odd number of items, you would just take the middle number, the midpoint, and that would be your median. But if you have an even number of items, you would find the middle two numbers and then determine your median either by seeing if they are the same or if they are different. If they are different, you would then add them together and divide them by 2 to get your median. So using our quiz score example, since we have 50 scores, an even number, after making sure that the distribution is in order from lowest to highest, we would then identify the 25th and 26th scores. Since they are both 18, we can determine that our median score is 18. So, accordingly, the median is a more representative measure of a central tendency than the mean since it better accounts for extremes, since it counts the number of items rather than the sum of the items. In this case, if the two highest scoring students got zeros on this quiz, we would redistribute the score, placing the 2 zeros at the beginning of the list. We'd then identify the 25th and 26th scores, 17 and 18, add them together and divide by 2 since they are different numbers, giving us 17.5. We'd then round that number up and determine that the median score in fact remains the same, 18. The mode is the point at which the largest number of scores occurs, the most frequently occurring score. In the psychology quiz, 6 students got the score of 17. Since more students scored 17 than any other, 17 is the mode. Although the mode is easy to compute, it is not very useful in describing the distribution of scores and is not affected by extreme scores. For example, suppose 4 students got zeros on the quiz and 4 scored 30. The mode is still 17. The mode is useful for learning what value occurs most frequently in a distribution. So when you want to know the most typical value in a distribution, use the mode. Manufacturers, for instance, use the mode to determine the best-selling items in their product lines, so they know to produce enough of those items to meet the demand. A set of scores can be arranged into a frequency distribution, which is a count of the number of scores that fall within each of a series of intervals. The scores are arranged from lowest to highest in a rank distribution, like these psychology quiz scores, then tallied. The scores range from 5 to 30, but 50 individual scores are difficult to work with. An easier way to manage the scores is to use a set of 2-point intervals, and then tally the number of scores in each interval. One way to picture a set of data is to create a frequency histogram. The frequency histogram is a type of bar graph that shows frequency distributions. Possible scores are shown along the x-axis, the horizontal line, and frequencies along the y-axis, the vertical line. Data can be depicted using a frequency polygon, a type of line graph that shows frequency distributions. In a frequency polygon, the frequency of each score is indicated by a dot placed directly over the score on the horizontal axis, at the appropriate height on the vertical axis. The dots for the various scores are then joined together by straight lines. If you recorded the grades of 1,000 students who took the introductory psychology course, your tabulations would show a distribution like this. In fact, if you take enough measurements of almost anything, you will almost always get a distribution like this. For that reason, it is called a normal distribution. Scores in a normal distribution tend to cluster in the middle of the range and then become less frequent toward either extreme. When we draw a line to graph this distribution, we get this bell-shaped line, known as the normal curve. Because the normal curve is symmetrical, the mean, median, and mode all fall on the highest point on the curve. If a distribution creates an asymmetrical curve, it is called a skewed distribution. What if a psychology class included one group of students who attended class and studied the material, and one group who did not attend lectures or study? Their exam scores might show a bimodal distribution, like this. A distribution is bimodal if it has two modes. For example, in this class, the mode at the higher level represents the scores of students who studied hard, while the lower mode represents those who did not work as hard. A measure of variability is a number that indicates how dispersed scores are around the mean of the distribution. If there is a lot of spread, that is, if the scores are widely dispersed, a distribution is said to be highly variable. Two measures used to quantify the variability of scores are the range and the standard deviation. The range is the difference between the largest and smallest scores in a distribution. For example, suppose 10 students took a psychology quiz worth 10 points. The highest score was 10 and the lowest score was 4. The range is 6, or 10 minus 4. Because the range is greatly affected by extreme scores, it is not very useful in describing the variability of a distribution. We only know about the two extreme numbers, 10 and 4. We know nothing about how much the scores varied within the range from 4 to 10. The standard deviation is a statistical measure of variability in a group of scores or other values. The higher the standard deviation, the more variability there is among scores. The standard deviation is defined as the average distance of each score in a distribution from the mean of that distribution. The farther the scores depart from the mean, the greater the standard deviation. Based on what you know so far about standard deviations, look at these two sets of scores and determine which set has a greater standard deviation. Click on the Answer button to find out. Although both sets of scores have the same mean, Group 1 has a greater standard deviation than Group 2, which means that there is more variability in this set of scores than those in Group 2. So in this case, Group 1 is correct. To further your understanding of standard deviation, we'll now find the standard deviation of the set of psychology quiz scores. First, we determine the mean. Then we take the first score in a distribution, subtract it from the mean, square the difference, and jot it down in a column to be added up later. We then do the same for all the scores in a distribution. Then we add up the column of squared differences, divide the total by the number of scores in the distribution, and find the square root of that number, which is the standard deviation. In a normal distribution, about 68% of the scores fall between one standard deviation above the mean and one standard deviation below the mean. Another 27% fall between one standard deviation and two standard deviations on either side of the mean, and 4% more between the second and third standard deviations on either side. More than 99% of the scores fall between 3 standard deviations above and 3 standard deviations below the mean. Inferential statistics are mathematical procedures used to make inferences about a population from a sample. Psychologists use inferential statistics to determine whether or not the results of their studies apply to the populations of people from whom research participants were recruited. Inferential statistics are used to predict behavior and to state its causes. In order to do this, the researcher must determine if he or she can have confidence in the measurements. In analyzing the results of their studies, psychologists must take into account the fact that their results may have occurred just by chance alone. Statistics give the psychologist many ways to determine if something other than chance produced the results, and if the same results would be obtained with different research participants. The most commonly used of these methods are significance tests, which tell researchers numerically how likely a result was to have occurred merely by chance. Suppose that a psychologist is interested in studying how sleep affects learning. The psychologist gathers a group of students and divides them between two groups, one that is kept awake for 36 hours and the other that is allowed to sleep during that time. Then the psychologist has both groups read a chapter from an introductory psychology textbook and take a quiz on the chapter material. Now suppose the group of sleep-deprived participants performed worse on their psychology quiz than a group who got enough sleep. The results might have occurred because the participants lacked sleep, or they could have occurred just by chance. The psychologist studying these groups must conduct statistical significance tests to determine how likely it was that the score difference would occur just by chance. Psychologists consider a result to be statistically significant if it would be expected to occur by chance 5 or fewer times in 100 repetitions of the same study, although some may require tests to show that the result would have occurred fewer than 1 time in 100. In an experiment on sleep deprivation and learning, the psychologist would say that a difference between the two groups is statistically significant if the difference is likely to be obtained by chance alone less than 5 times in 100. Another way of saying this is that the result is significant at the 0.05 level. Statistically significant results allow psychologists to make predictions and state the causes of human behavior, and they can make these predictions for whole populations of people, not just those who participated in the study. If, for example, a psychologist found a statistically significant difference between the learning performance of sleep-deprived participants and performance of participants who got sleep, the psychologist could predict that all students who lack sleep are likely to suffer decreased learning ability. The results are not limited to just those students who participated in the study.